We left off with J.J. Thomson, who had the plum pudding model discovered the electron, but he didn't know what the positive part of the atom was. He knew it existed, but that was beyond his studies. So Rutherford comes along. He's also exploring this atom. He does a gold foil experiment, which we're going to take a look at now.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles
We would say much more dense in our classroom.
themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening.
So what they're seeing here is you see all those little gold atoms, right? And over here, these are the alpha particles. So again, they couldn't see this with their eyes or a microscope. This was way too small. But this is how he imagined the experiment must be at that particle level. That the little alpha particles, that beam he was shooting through the gold foil made of the atoms, that most of the atom is empty space and they went right through. However, if one of the alpha particles managed to get near the positive nucleus, they would be repelled back. Alpha particles are positive, the nucleus is positive, and they repel each other like charges repel.
Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle. In 19
Okay, so let's go back to our evidence and put this together. There were two pieces of evidence. So, first, 99.999% of the alpha particles went right through the gold foil like nothing was there, because nothing is there. Atoms are empty space, not air, empty space. Okay? That means you are 99.999% empty space. The wall is 99.999% empty space. Theoretically, we should be able to walk through walls. There's a reason we can't. We'll talk about it. But we are. We're empty space. The chair is empty space. Everything around us, all particles are mostly empty space. Okay? But there is something in that empty space that's important. Okay? And the second piece of evidence proves this. He was sending positive alpha beams or particles through the gold foil, and some of them would bounce back. Why? Well, what reflects or repels positive? Something with a like charge, another positive. So from this, he was able to imagine, deduce that there was something in that empty space, okay, that was positive and very dense. Okay, we're going to use the word dense. That's where all the mass of the atom is. Now, today we know those are protons and neutrons in that positive nucleus. Right? Then they just knew it was a positive, small, tiny nucleus and a lot of empty space with electrons whizzing around. And this led to his model, the nuclear model. In the nuclear model, you have the positive nucleus with protons and neutrons in there, and electrons are in this empty space whizzing around. And they didn't know how they were moving. That would come later.